This video is going to look at solving trigonometric equations. One of the issues that's involved with solving trig equations is that if there is a solution, there are infinitely many solutions. So we have to find a way to describe the infinite solutions because obviously we can't write them all out. So if you take a look here, our equation is the sine of x equals 1/2. So the blue curve here is the sine of x, and then the red line is the 1/2. So as you can see from here, we've got 10 different solutions in the window that I've shown here, but we know that that sine curve goes forever in both directions, continuing that periodic motion, and the line goes forever in both directions. So it's actually going to give us infinitely many solutions. So when we're solving a trig equation, what we want to do is find the solutions within one period of the function. Remember, for this graph here, sine x, we're going to say that the period would be 2 pi divided by b. There's nothing in front of x, so that's just 1. So my period is 2 pi. So if we look at the period of 2 pi, so starting at 0 and going over to x equals 2 pi, we can see that there's actually two intersections in that period. So within my period, I have two solutions. And then once I find this first solution, if I add the period, I'm going to get here. If I add the period again, I'll go here. If I subtract the period again. So half of my solutions are coming from that first solution in that highlighted region, and then adding or subtracting the period. And then my second solution in that highlighted region, if I add the period, subtract the period. So the other half of my infinite solutions are coming from that second answer in the highlighted region, and then adding or subtracting the period. So what we can see then is we just need to find the solutions within one period, and then we can add or subtract the period any number of times to find other solutions, or to write our general solutions, or to describe our infinitely many solutions. So in general, what we want to do is what we started with here. We want to find the period of the function, and then we're going to find this first solution right here. So in order to find that first solution right there, what we're going to do is just take our equation, sine of x equals 1/2, and we're going to try to get x by itself. So to get x by itself, we have to remove the sine, and in order to do that, we have to do the inverse sine to both sides. So remember, if I do inverse sine of x, that's just going to leave me with x, so then I'm going to do inverse sine of 1/2. Now remember, with inverse sine, I can use my unit circle, or I can use my calculator. So again, it's just going to depend upon the directions, whether it asks for exact values or approximate values, or it tells you can round. So on this one, we're just going to practice using the unit circle, and we'll do exact values here. So if we go to our unit circle, where is our sine value? 1/2. That happens right here. So if I'm working in radians, I'm going to give an answer of pi over 6. So here we will get x equals pi over 6. So that's my first solution in the highlighted region. Then to find the second solution in the highlighted region, we have to think about the symmetry of the graph. So you can see that if I were to fold right along this line, I have some symmetry in this curve right here. So this point that we have circled in green here and this blue dot here, they would be reflections of each other if I were to fold along that line. So the distance from the y-axis to this first point is the same as the distance from pi back. So what I'm going to do to find that second solution using a sine function is to say that my second solution is 1/2 of my period minus my first solution, because the symmetry always comes at this halfway point. So then we're going to say x is pi minus pi over 6, which is going to give us 5 pi over 6. So then this second solution right here is the 5 pi over 6. So what are my solutions between 0 and 2 pi? My solutions are x equals pi over 6. And x equals 5 pi over 6. And then remember, if we want to describe all of the solutions, we just take those two solutions that we found, and we're going to add or subtract the period any number of times. So what we do is we say x equals pi over 6 plus 2 pi, which is my period, n, and we can say n is any integer. So that means we can add add or subtract the period any number of times. If n is 1, we're going to add it once. If n is 2, we're going to add it twice. If n is 3, we're going to add it 3 times. If n is -1, we're going to subtract it once. We're going to do the same thing with the second solution, so we're going to go 5 pi over 6 plus 2 pi n. Again, n is any integer. From this point forward, we're going to just we're going to all assume that we know n means any integer, and I'm not going to write it out every time, nor will you have to write it out. All right, so let's take a look at this example. We have solved 3 cosine x minus 4 equals -2. So the first thing we notice different from the previous equation, other than it has cosine, is that the cosine x is not by itself. So that's the first thing that we're going to want to work on with this equation, is we're going to add 4 to both sides. So we get 3 cosine of x equals +2, and then we'll get cosine of x equals 2/3. And again, you can see that's what I have graphed over here. The blue curve is the cosine of x, and the red line is the 2/3. Again, we're going to think about the period of the function. So this period is 2 pi divided by b, which is 1. So my period is just 2 pi. So again, I'm going to do similarly to what we did before. So if I highlight one cycle, so from 0 to 2 pi, so one cycle of my cosine curve, I can see again that I have the 2 intersections in there. So my infinite solutions are going to come from those 2 intersections again, and just adding or subtracting the period, just like we did last time. So here's my first intersection, and I can add the period or subtract the period any number of times, and we would get these additional solutions. And then we can take the second intersection or solution that happens in that highlighted section, and we can add or subtract the period a certain number of times, and we'll get the other set that gives us our infinite solutions. So again, we're going to work similarly to what we did before. So I'm going to start with that cosine of x equals 2/3. So we want to first get the x by itself. So x is, remember, to get rid of cosine, we have to do inverse cosine. So I'm going to do inverse cosine of 2/3. 2/3 is not on my circle, so I wouldn't be able to do the exact value here in this case. So we're just going to go to our calculator at this point. Make sure your calculator is in radian mode. And then we're going to do inverse cosine, so second cosine of 2/3. And let's just round that to 2 decimal places. So we're going to go x is about 0.84. So this first intersection here is about 0.84. Again, I want to find that second solution within the period, so in that highlighted region. So here again, we're going to look at the symmetry of the graph. And here you can see if I were to fold along the pi, then I'm going to get a reflection here. So the distance from the x-axis to that first intersection is the same as the distance from 2 pi backwards to that intersection. So again, we're going to subtract, but this time we're going to subtract from 2 pi, so we're going to subtract from the whole period. So my second solution here is x equals my period minus my first solution. So in this case, that's going to be 2 pi minus the 0.84. So just using our calculator there, we're going to get 5.44. So what are our solutions between 0 and 2 pi? Our solutions were 0.84 and 5.44. So if we want, what are our general solutions? So this would be all infinite solutions. So now we're going to go x equals the 0.84 plus our period, remember, which is 2 pi, and then we use the n, remember, so that means we can do any number of times. We're not going to write the n, means any integer from here on out. So then we're going to do x equals 5.44 and then plus 2 pi n. So that would be my general solutions, or all solutions. All right, so we did a sine example, we did a cosine example, so now we're going to look at a tangent example. So again, with this equation, the first thing I'm going to do is get the tangent by itself. So I'm going to go tangent of x equals 7/8. And again, you can see over here, my blue curve is the tangent of x function, and then the red line is 7/8, so that's what we're looking for. Again, you can see we have infinite solutions. The difference with tangent, remember, is that my period for tangent is simply pi divided by b, and in this case, b is 1 again, so my period is just pi. So if I highlight the curve of the one period of the tangent curve, which is from 0 to pi, what we notice is that there's only one intersection in there. So with tangent, we just get the one solution and we don't have to find a second solution. So that's why it makes it a little bit easier here. So here we're just going to, again, start with tangent of x equals 7/8. We want to get x by itself. So x equals inverse tan of 7/8. Again, that's not a value that we could get from the unit circle, so we're going to use the calculator. So I'm going to do inverse tan or second tan of 7 divided by 8, which is going to give me, again, we'll round to 2 decimal places, so we get about 0.72. And then all of my other solutions come from just adding the period, which is pi, or subtracting the period, which is pi, and all of my infinite solutions will come just from that. So what are my solutions between 0 and pi? I just had x equals 0.72, and then find my general solutions. X is 0.72 plus my period. Remember, my period in this case is pi, and then n. So that would be my general solutions. So if we just kind of generalize the process here, the first thing you want to do when you're solving a trig equation is find the period of the function. So remember, for sine and cosine, that's 2 pi divided by the absolute value of b, and pi divided by absolute value of b for tangent. And for both of these, we're saying b is the coefficient of x. The next thing you want to do is make sure that you isolate the trig function and its argument, so get the sine, cosine, or tangent by itself. So sine, cosine, tangent equals, and then your constant should be on the other side. Then you're going to take the inverse trig function of both sides of the equation. So this would be done either by using your unit circle if they want exact values, or your calculator if you can give an approximate solution or they tell you to round. Next, you're going to isolate the variable, so get x by itself, and then you're going to find the second solution within one period if it exists. So for sine, remember, that's always 1/2 of the period minus your first solution. For cosine, it's the whole period minus the first solution. And for tangent, there is no second solution. Once you do that, you can determine any other solutions that you need by adding or subtracting the period, or remember, if they ask for general solutions, then you want to go and add the plus period n. Okay, if we take a look here at how we could solve these using your calculator, so the calculator is going to give you approximate values, decimal values. So the first thing that you would want to do, I would still solve so that you have isolated your trig ratio, sine, cosine, or tangent, and then your constants are all on the other side, and you still want to find the period. So then in your y1, put the left side of the equation, and your y2, put the right side of the equation. So you can see here I did cosine x and 2/3. Then what I would do is start with a zoom 7, which remember is your zoom trig, to just kind of set your window for a trig equation. Then I would press my window button and I would go back and I would set the x min to 0 and the x max to whatever your period is. So in this case, your period is 2 pi, because remember, you're always going to find your first two solutions for sine and cosine within one period. So once you do that, then you can just press your graph button and you can see your one period of the graph, and then you can see your two intersections, and now we can just do second trace intersection to find those solutions. So we've got this 5.44 over here, and then we would have to go back second trace intersection and then kind of scoot over towards this other one, and then we've got the 0.84. So we can do that with any equation, sine, cosine, tangent, doesn't matter. The exception would be if you need exact values. Obviously, you're not going to be able to get those from your calculator, so it would be a situation where you're doing approximate values.